Audio Jungle. Audio Jungle.
So problem number, this is problem number 1. Okay, we are talking about jet propulsion problem. Jet propulsion problem. So we write an aircraft flies at 960 km per hour. Okay, one of its turbojet engine engines takes in 40 kg per second of air and expands the gases to the ambient pressure. The air fuel ratio is 50 and the lower calorific value of the fuel is 43 megajoule per kg. For maximum thrust power condition, determine number 1, jet velocity means VE. Number 2, thrust T. Number 3, specific thrust. Number 4, thrust power. Number 5, propulsive efficiency, thermal efficiency and overall efficiency. Number 6, SFC. So this is the question. Okay. See, in examination, question will be like this only. Dicto. Question will be like this only. But here, for this problem, how many parameters asked? 6 parameters. But in examination, one or maximum 2 parameters will be asked to you. Rest everything will be same. So this is the format of the question. Like this type of question will be asked. Okay. So very simple, only formula based. First we have to find what the value they have given, because that one is very important. So see, aircraft flies at 960 kilometer per hour. So this is what V infinity, which is also called aircraft flight speed. As per our notation, it is V infinity. I told you free stream velocity is also aircraft speed. Okay, one of its turbojet engine takes off 40 kg per second of air. So m dot a, it is given m dot a, and expand the gases to the ambient pressure. So what is the mean of this? That expansion is what? Fully expansion condition, because ambient pressure means that exit pressure reach to atmospheric pressure. So it is PE is equal to PA, that condition. So wording is very important, and many times I have explained this statement. Okay, like fully expansion, optimum expansion, or expands to gases, expansion to the atmospheric condition or to ambient pressure condition. So these are the different statements. The meaning will be same. PE is equal to PA. Okay. The air fuel ratio, they have given air fuel ratio is 50. The lower calorific value of the fuel, which is nothing but HV, heat value, or CV, it is also called HV or CV, I told you. For maximum thrust power condition, determine, these are the value. Okay. So see, what are the given data here? That aircraft speed, V infinity, it is given how much? 960 kilometer per hour, right? 960 kilometer per hour. So you just convert this 960 kilometer per hour. So it is nothing but I think 5 by 18. Yes or no? 5 by 18, I think. So you need to find this speed first. So it is nothing but 266.66 meter. What is the next value they have given? Turbojet engine takes of air. So m dot a. Okay. That air they have given to us. What is the value of m dot a? It is 40 kg per second. Okay. So 40 kg per second, and expand the gases to the ambient pressure means PE is equal to PA, it is given. Okay. The air to fuel ratio is given. Air to fuel ratio means m dot a divided by m dot f. Okay, it is given 50. What is small f? Small f is fuel by air, or m dot f by m dot a, it is given how much? 1 by 50. So 1 by 50 is nothing but 1 divided by 50 is nothing but 0.02. So this is the value of a small f. Okay. And HV is given how much? 43 megajoule. Calorific value, or it is called heat value, 43 megajoule per kg. All right. So we'll go for the solution. So what is the condition they have given to us? The condition is given condition. The condition is maximum thrust power. What is the maximum thrust power you had derived? It is alpha is equal to 1 by 2. If you remember, what is the alpha? The speed ratio, and this speed ratio was what? It was V by V infinity by VE. V infinity is nothing but aircraft speed divided by exit speed. Okay. What is the first problem? Jet velocity, exit they are asking. So we can get this. What is the alpha value? It is 1 by 2. It is nothing but V infinity divided by V exit. So what is the V exit? It is 2 times of V infinity. V infinity is nothing but 266.66. Just find this value. How much? 266.66 into 2. It is coming 533.32. So this is nothing but VE 533.32 meter per second, or what was the aircraft speed? 960, na? So 960 into 2, it is 920, or you can write 1920 kilometer per hour. This is the answer. First, hope so you understood this. Very simple formula based one. All right, this is the one. Okay, here you are calculating first jet velocity. What is the next need to calculate? Thrust. Okay, second number is thrust, T. So what is the thrust? Thrust you know very well. It is m dot a. Again, I'm not going to derive thrust formula. It is already derived many times. So 1 plus f VE minus V infinity plus T minus T infinity into H. P infinity into PA. Okay. So as you have seen that gas is what expanded to the uh, atmospheric or ambient condition. So here you can say this is the whole scenario. Okay. This is the combustion chamber, m dot f. This is m dot a, m dot a plus m dot f. What is the velocity here? It is v exit. Yes or no? And what is the velocity here? It is v infinity. What is the atmospheric or ambient pressure? P infinity. Exit is PE. Okay. So if it is fully expanded or gases are expanded to the ambient condition, then P is equal to PA. Okay, so this is the condition. Now if you check this, so this part will be now, it will be 0, because it is clearly mentioned in the problem that gases expands the gases to the ambient pressure. Okay, so PE is equal to PA. It is clearly mentioned in the problem. So now what is the thrust? Thrust is nothing but m dot a 1 plus f ve minus v infinity. So we'll write all the value here. Check. So your thrust will be m dot a, which is given 40 kg per second. 1 plus f is nothing but 0.02. What is the ve? You had seen ve is nothing but 533.32. 533.32 minus 260.66, that is the v infinity, which is the where aircraft is made. So I am getting here 11.11.093.05 at Newton, or you can say it is approximate to 11.093 10 to the power 3 Newton, or you can say 11.09 kilonewton. This is what thrust. Okay, this is the value of thrust. Right. So this was the second number. Third is specific thrust. So we'll calculate specific thrust. Specific thrust. What is the formula? Specific thrust. Fs is equal to, it was thrust per unit mass flow rate of air. So what is the thrust? You have calculated 11.09 or 11.093.58 divided by 40 kilogram per second. If you calculate this value, Fs. Check thrust formula. Previous problem where I have calculated thrust is what? M dot A 1 plus F VE minus V infinity divided by M dot A. So write properly. Okay. Fs is nothing but 1 plus F. F is the fuel air ratio, which is 0.02. You have calculated. VE, it was 533.32 minus 266.6. If you do this, check how much you will get. 1.02 into 533.32 minus 266.66, 277. I don't know why you guys are getting 271. 277.32. This is, what is the unit here? It is Newton per kg. This is the value of specific thrust. So this is the specific thrust, right? What is the next value we need to calculate here? Check. Specific thrust is done, and the next one is thrust power. Okay, so thrust power we need to calculate. Third is done. Fourth number. What is the fourth number? Fourth number is thrust power. Thrust power. I told you it will be denoted by TP, thrust power. Okay. Now thrust power is nothing but power. What is the power? Power is nothing but force into velocity, right? What is the power here? It is thrust power. Thrust power. So what will be the force? Thrust What is the velocity? Aircraft velocity. What is the thrust we have calculated here? Check 11.093. 11.093 into 10 power 3. It is thrust into aircraft velocity you had calculated. It was, I think, 266.66. If I am not wrong, please check it. So what is the thrust power? If you do this, then 11.093 into 266.66. So this is nothing but 295. It's a huge value actually. So let me write complete. 295.8059.38. It's a power, so watt, or you can say 1 2 3 4 5 6, so you can say 2.95 megawatt. This is what thrust power. This is the thrust power. What is the fifth point? Fifth point is nothing but eta p, eta th, and eta o. So see this, there are two methods to calculate this value. One is well known, that formula only you can use, all the efficiency formula like eta p. You know how to get that eta p. You know that value of eta ts, how to get, okay, for turbojet. So if you go for the eta p, so eta p is nothing but 2 alpha divided by 1 plus alpha. Here the condition is what? Maximum power condition, maximum thrust power condition. So what is the alpha value? Alpha value is nothing but 1 by 2. Now, so what you will do? You will write 2 into alpha is nothing but 1 by 2 divided by 1 plus alpha is 1 by 2. If you solve 1 divided by 3 by 2, or you can say 2 by 3, it is nothing but 0.666, or eta p directly here you can say 66.66%. All right. This condition they have given to us. What is the condition? Maximum thrust power condition. And for maximum thrust power condition only you are calculating all the values. All right. So eta p you have calculated. Now we'll go for the eta th. What is the formula for the eta th? Check. So the eta th is nothing but what is the eta th? It's a thermal efficiency. Okay. So thermal efficiency formula for the turbojet, you know, it is nothing but, if you remind, it is VE square minus V infinity square. Okay. And in fact we have the value of f, so we cannot ignore that value, that part which is small f, we cannot ignore. So that formula I need to write. What is the complete formula? If you remind, eta th is nothing but, it is 1 plus small f VE square minus V infinity square, okay, divided by 2 into small f into HV. So 1 plus 0.02. What is the VE? If you remind, you have calculated 5.3332 square minus 266 square, 266.6, 2 into what is the F? 0.02. What is the HV? It is megajoule. What is the megajoule? I think 42 or 43. Check. 43 megajoule. 43 megajoule, right? So 43 into power 6. So if you calculate this value, what will get? Do it. So 1.02 into 533.32 square minus 266.66 square divided by, in bracket, 2 into 0.02 into 43 megajoule. Here I am getting 0.127. I am getting 0.127. Okay, I am getting 0.127, or you can write 12.7%. This is the thermal efficiency. 0.127 if you solve it. Okay, we'll go for the next. What is that next value? We need to calculate overall efficiency. What is the overall? Eta P into eta TH. So how to get it? Eta O. What is the eta P? Eta P is 0.66 into what is eta T is 0.127. Now we will calculate 0.666 into 0.127. It is 0.0845. So what is the overall efficiency? You can say multiplied by 100 will give 8.45. This is the overall efficiency. This is the overall efficiency. Okay. So now the last one is the 6th number, which is nothing but SFC. Okay. Last value we need to calculate. It is nothing but SFC, which is nothing but specific fuel consumption. All right. So I had given formula for the SFC. It is mass flow rate divided by thrust. Means for the given mass flow rate, what is the produced thrust, called SFC. Okay. What is the amount of the mass flow rate? Check. We had calculated or somewhere, or it is given that value m dot f. Anyway, we can get from this m dot a by m dot f, which is 50 given, m dot a 40 kgs, mf we can get. Okay. So one thing, thrust we already have calculated. Okay, one by one we'll do. What is the thrust? It is 11093. Fine. So we can write this value. Okay. So how to get the mf value? So see, we know or we have m dot a, air to fuel ratio. In the problem itself it is given how much? 50. Okay, 50. This ratio is given to us. What is the m dot f? M dot f will be m dot a divided by 50. What is m dot a? It is also given in the problem, 40 kilojoule per second divided by 50. So it is nothing but 40 divided by 50, right? It is 0.8. So now SFC we can get here. It is 0.8. Thrust is nothing but 11,093. This is the thrust value. 0.8 divided by 11,093. So what I am getting here, it's 0.72. Thrust is correct, right? Mass flow rate per unit thrust. So this value will be, so if you calculate this value, so this is nothing but 7.21 into 10 to the power minus 5. Okay, the unit will be kilogram Newton per second. This is the specific thrust. So please one more time you go cross check. You can, whatever value you have calculated, you can cross check also, because sometimes calculation mistake possibility is there. So you can cross check even though in examination also, if you have time. Peacefully you have to calculate, no hurry, but your time constraints is there, and once time constraint is there, then you have to focus on that also. It means you have to match that. If any numerical taking so much time, you can skip, forget about here, because here we have calculated 6 values for one problem. I told you in examination, for one problem they will ask max to max 1 or 2, maximum 2 value they will ask to you. So within minutes you can finish. Okay, all right, all right. So now we have problem number 2. Problem number 2. Check. A turbojet engine is, so turbojet engine is powering is powering a fighter airplane, powering a fighter airplane. Okay, powering a fighter airplane. Its cruise altitude, and and Mach number are 10 kilometer and 0.8 respectively. The exhaust gases leave the nozzle at a speed of 570 meter per second and a pressure of 0.67 bar. The exhaust nozzle is characterized by the ratio A by m dot A is equal to 0.006 meter square second per kg. The fuel to air ratio is 0.02. It is required to calculate the specific thrust. What is the specific thrust? T divided by m dot A. Okay, this is the question. This is the question. Okay. All right. So check in the problem. Altitude they have given 10 kilometer. Mach number they have given 0.8. Exhaust gases leave the nozzle at a speed of 570 meter per second. Exhaust speed also given. Pressure PE is also given. Okay, exhaust gases leaves the nozzle at speed and pressure at the exhaust it is given. The exhaust nozzle is characterized by AE by m dot A. Okay, all right. So the fuel air ratio is given. It is required to find. So this is the problem. Now, if you check all right. VE and PE. What is the PE? They have given 0.67 bar. And this aircraft is what flying at 10 kilometer altitude. So whatever the air, it is obviously V infinity, and mass flow rate will be m dot A. But at this altitude, temperature and pressure will be required, no? Because what is the condition we don't know, no? At 10 kilometers, so we need to calculate that. And this is the engine, this is the aircraft, not engine. When engine I am showing, but aircraft is not flying here. Okay, all right. Compressor, combustion chamber, this is the condition of the engine here. Okay, so in this engine, if you check, velocity be infinity, but at what temperature and what pressure it is, we need to calculate at 10 kilometer. Because whatever the value they are asking, why I am saying temperature and pressure required, because if you see, if you go for, and one more thing, at 10 kilometer, and the Mach number is given here. What is the Mach number? It is mentioned. Mach number is 0.8. Check. Mach number is 0.8. Okay. So this is the nozzle part, and this is the diffuser part. Okay, fine. So they are saying calculate specific thrust. So let me write first thrust formula. What is the thrust formula? So complete formula you have to write momentum thrust and pressure thrust. What is the momentum thrust? it is nothing but m dot a 1 plus f ve minus v infinity plus pe minus t infinity into ae. Yes or no? So here what they are saying is specific thrust. So what will be the specific thrust? It will be Fs. What is the Fs? Thrust divided by mass flow rate. So here in this formula you just divide by mass flow rate both sides. So you will get a specific thrust, and here you will have this m dot a will be divided this side. So this is nothing but 1 plus f okay. All right. So now formula you have now. If small f, anything about the small f, which is the fuel air ratio, if it is given to you, okay, then you use this. Otherwise you can ignore also, no problem. Check in the problem it is given or not. See, fuel to air ratio it is given 0.02. So it means small f they have given, okay, small f they have given. Exit velocity, exhaust condition they have given, see 570 meter per second. What they have given, m infinity 0.8, ve 570 meter per second, pe exhaust condition pressure 0.67 bar, and small f which is the fuel air ratio 0.0. These are the given value. Yes or no? Now, so in the formula what are the given value? Small f you have, ve you have, v infinity you don't have, but Mach number they have given, so you can calculate. Pe you have, but p infinity we don't have. So first of all, at 10 kilometer we need to calculate p infinity and t infinity, then you will calculate v infinity. How? Check. At at 10 kilometer altitude, which is nothing but troposphere, we need to calculate temperature and pressure. How to get this? In troposphere I told at 10 kilometer, in performance I have taught you T infinity minus lambda into h. Here T infinity, better don't say T infinity because we have denoted T infinity as a free stream. I must say sea level, okay, into lambda h. What is the sea level temperature? It is, I think, 288 Kelvin, right? 288 Kelvin minus lambda is 0.0065. What is the h? 10 kilometer. If you do this, then you will get temperature at, so 0.0065 into 10,000, 65, 288 minus 65, so we have 220. This is the temperature at 10 kilometer. Okay. Similarly, we need to calculate. So we need to calculate pressure. So what is the formula for the pressure? If you remember, pressure at 10 kilometer divided by pressure at sea level. Okay. The formula is temperature at 10 kilometer divided by temperature at sea level to Hood power G by lambda R. Okay. If you remember, I had given T 10 kilometer divided by T sea level This g by lambda r we had calculated and we got that time 5.25. If I am not wrong, you can check. G is 9.8 divided by 0.0065 divided by 2, 287. 5.2, correct. So P 10 kilometer we can write P at 10 kilometer P at sea level into T 10 kilometer T at sea level to 5.25. What is the sea level pressure? 101.325 Newton per meter square into 10 kilometer. Just now you have calculated temperature 223 divided by 288 to whole power 5.25. So what is the temperature at 10 kilometer? It is nothing but 223 divided by 288 to whole power 5.25 multiply 101.325. It is 26454 sorry 454.92 Newton per meter. So this is the value of pressure at 10 kilometer. Okay, or in bar you can write you can say 0.26 bar also is better, right? Okay, it's your choice. This is the 10 kilometer pressure. Now we can have all the value check in the formula. What is required? I think all you have calculated, only V infinity you have not calculated. That also you can calculate because temperature you have now. So what is the Mach number? M infinity is equal to speed of the aircraft divided by speed of sound. So it is V infinity. What is the speed of sound? It is root of gamma r T infinity. T infinity in the sense what? Temperature at where the aircraft is what flying. So better you say it is T infinity. What is the V infinity value then? Mach number M infinity. Okay, so Mach is what? 0.8 you have. 1.4 considering as a air. 287 temperature what you had calculated, it is 223. 223. So write this value 1.4 287 multiplied by 223, take root of it, multiply 0.8. It's a 239.46 meter per second. Okay. So this is the way. Now everything you have, now all the value what you have calculated, all the value you have to write in this formula. Now write 1 plus f v e minus v infinity p e minus k infinity. So it will give a specific thrust. So now the specific thrust Fs. P divided by m dot 2, it is nothing but 1 plus small f ve minus v infinity plus all value you have to write here. P by 1 plus f. F is given how much? 0.02 I think given. Na? Let me check. 0.02. So write this value 0.02. VE, that value it is given how much? It is 570 meter per second. 570 meter per second. Minus 239 I think, 239.46 plus PE, exit pressure what they have given, it is given 0.67 bar PE, and what is the P infinity you have calculated, it is 0.26 bar. Bar means 10 to the power 5. No? Now you calculate this value. Check. So 0.67 minus 0.26 into 10 to the power 5 0.67 minus 0.26 into okay plus in bracket 1.02 into 570 okay minus 239.46 is coming this value. So see the small correction you have to do here. The small correction what I made mistake, please correct it. E we have, okay, this is the formula, first formula, and once you get a specific thrust you need to divide by m dot a both side. So if you divide both side, then this formula will be here a is there, so obviously a divided by m dot a, that I missed now. Okay, why I remember this, because in the problem itself a by m dot a they have given. Check this. So when I was cross checking the answer, so I immediately I saw this a by m dot a, so that we had not used. Obviously in this equation if you check, if you get a specific thrust after dividing by m dot a both sides, so a by m dot a how you can, so actually it was missed, no? So please correct this. So a by m dot a, so here need to write a by m dot a, and this is nothing but a by m dot a. So please correct this value. What is the a by m dot a they have given to us? 0.06 I think. Check. 0.006. 0.006. Please correct this value. 0.006. 0.006. Now you need to calculate the value. Please correct that, and once again, so don't be in a hurry. You calculate if you want separately. If you want to calculate separately, you calculate. So 1.02 okay into 570 minus 239.46, so you will have 341.94 plus this 0.67 minus 0.26 okay into 0.006, that is a by m dot a okay into, right, and you will have 10 to power 5, that is bar. So if you get this, it is nearby 584. Yes or no? Approximate to this value, you please check. This is nothing but 0.67. Sorry, I'm doing late actually, because in my calculator I'm not able to go fast because it's old one. 0.67 minus 0.26 into 0.06, 2.46 10 to the power 3 into 10 to the power 5. So I will get 246. So if you add this 341.94, then it is nearby 587 in my calculator. I'm getting. You please cross check this. It's nearby 584, 583. That one is to getting. It's correct one. What is the unit? Unit is Newton by kg per second. This is the answer. So you also cross check it. Okay, maybe 584, 583, 587. It's nearby only. A little bit variation if you have.